Fantastic. Next we have a question for George Abbey. What are the three main qualities that you look for when choosing someone to travel into space?
Well, if you look at an astronaut who flies, he really is a member of a team. He's part of a crew, and then he also works with people on the ground to support the mission in the control center and scientists that he's working with and doing the experiments. So you want an individual who can work well as a team member. You don't want an individualist. And you, of course, as an astronaut, you're going to get involved in doing a lot of experiments, a lot of work for other people. So you have to have a science or an engineering background in order to be able to understand it and do it well. But you also have to have a desire, I think, to do and be interested in many things. Because when you fly in space, you might have a background as a medical doctor, you might have a background as an astronomer or a physicist, but you're going to get involved in experiments that are far afield from what your background is. So you have to have an interest and a desire to get involved and learn new things. And of course, I think overall you need to have that engineering and science background, and that carries through for also the people that support the mission. And so if you're going to really get involved in the space program, getting a good background in science and engineering is going to be very important. So I hope all of you are doing well in math and science, and will get involved in the future and go into university and get involved in those fields, because the UK and all the countries around the world have a lot of issues and problems over and above space that need good engineers and scientists. So I hope you'll all get involved in that area.
And another question for Chris Orlebar.
How did you feel when the Concorde took its last flight?
That is a good question. Of course, very sad, but we could see it coming. The last flight of Concorde represented a step backwards from the future. When we went into service in 1976, I can remember it was all fly the future, fly the flag. And in 2003, the future seemed to be twice as large an Earth as we'd had before. I've got to say that the speed of sound and the size of the Earth are just about the wrong ratio which you can imagine. The Earth isn't quite small enough, or the speed of sound isn't quite fast enough to make sitting in a seat satisfactory for those long distances. And if the Earth was much bigger, you would have to have a cabin with a bunk. Well, I'm all for travelling at twice the speed of sound, or even faster. And so the sadness when Concorde stopped flying was the realization that we hadn't taken the next step. We had taken the difficult step in the pre-digital computer age. And if only we could have updated those Concordes with more effective digital computers, we would have reduced a great deal of the weight of the aircraft. And to give you an idea of the way we burn fuel, if you wanted to end up with an extra ton of either fuel or passengers or equipment at New York, you would have to load on an extra ton at London. So it would cost a ton of fuel to carry an extra ton. And the same if we managed to reduce the weight of the aircraft in all sorts of ways, we would have gone further, been quieter, etc. That was my sadness.
And we have another question for Richard Garriott.
Why was it worth $13 million to travel to space?
So for me, when I was about your age, I decided I was going to go to space if it was at all possible. And so for me, it was not a question of how much did it cost. Like, did I happen to have that money sitting around? I made the decision that I was going to find a way to earn whatever amount of money that it took to be able to go into space. And that was just a decision I made when I was when I was your age. It was just that important to me. And so I've tried many ways to get into space. I invested in a lot of early companies, like one still around called Spacehab, that I'm sure George remembers well, that flew hardware in space and inside the space shuttle, because their original plan was to take passengers, and I wanted to go. but that wasn't going to work out. So then I invested in a bunch of suborbital spaceplane companies before any of them really, before now they now exist, but before any of them ever won the X Prize. I then became one of the founders of the X Prize and Space Adventures and Zero G Corp. And then finally we found a way with the Russians to arrange a trip to space. And even then, the first time, I was originally going to be the first private citizen in space, but that was when the internet stock market crashed a few years ago, and we had to sell my seat to a guy named Dennis Tito, who became the first person to fly into space. And so I had to go build another company and earn more money in order to finally be able to get this chance to go. So I've literally spent 30 years building personal assets and building companies to open the door for not only myself to go to space, but hopefully for all of us to ultimately be able to go to space in the near future.
And we have another question for Colin Rowe.
How long does it take you to design a rocket from the original idea to the first prototype being tested?
Well, that depends on what we're going to do. If I take the shuttle, which was the biggest project size-wise that we've done, it's not the tallest. I think on that, to actually design it from when we got the first idea from Top Gear, and that's what they wanted, was 4 weeks to totally design. I think it's 20,000 different parts in it. So 4 weeks to do that. And then to build it was about 10 weeks. So it's a very, very short timescale opposed to proper aerospace things. A lot of it, we don't actually test the prototypes. What you see is its first flight. The things that we make are designed and built to fly once, and usually they're only put together when we're going to launch them. The space shuttle didn't get put together until it was actually on the launch pad to be filmed, which was a bit scary. Theoretically, it should have fitted together, but as you know, in NASA sometimes some people use different dimensions or think differently and they don't quite fit together. But luckily everything went together within a few millimetres, and yeah, it worked quite well until the final part. But to design it and build it is a very, very short time scale, but it's very stressful and very hard work, and it comes back to you've got to be quite dedicated to do this sort of stuff. And it goes back to what George was saying, you need your science and your math to do it as well, because I'm not in the same league as these guys here. I'm self-taught and everything. I started off like you were doing, just flying little rockets, interested in science. This is where I've ended up. So if I can do it, Mr. Average, I think anybody down there can do it if you really want to do it. Same with everybody here. If they want to do it, they can do it. So in answer to your question, yeah, it's about 10 to 12 weeks in total for the most complex one. Blue Beaker rocket was 6 weeks from start to finish, so it's a very short time scale.